The beginning of everything. The Big Bang. A singular moment that started it all.
The universe was suddenly born, bursting forth from nothingness into an expanding reality. For a long time, we believed the universe was infinite and had no beginning. Scientists in the 20th century viewed the cosmos as eternal and unchanging. But new theories would soon challenge this static view of our cosmos. Einstein's groundbreaking theory of relativity completely changed our understanding of gravity. This new perspective allowed us to model the universe's behavior mathematically. Then, Edwin Hubble discovered that distant galaxies are actually moving away from us. This observation perfectly matched the predictions of an expanding space. If everything is expanding now, it must have started from a single point. In 1964, a major piece of evidence was found entirely by accident. Scientists detected a faint, persistent hum coming from every direction in space. This was the cosmic microwave background, a relic of the early universe. This discovery, solidified the Big Bang as the leading scientific theory. Since then, advanced space telescopes have given us an even clearer picture. We can now observe the deep structure of the cosmos in incredible detail. But the question remains, how did this incredible expansion actually work? How could everything we know come from absolutely nothing? To find out, we must look at the phase known as inflation.
First, we must understand that the Big Bang was not an explosion.
It was space itself, stretching everywhere, all at once, in an instant.
The universe started unimaginably small and grew to the size of a football. It didn't expand into anything because there is no outside to the universe.
Space was simply stretching into itself, defying our everyday intuition.
Yo, humans! I'm really happy for you, but your brains are not that good at visualizing this stuff.
After inflation, the universe entered a hot, dense phase called the quark era. In this extreme heat, energy began to manifest directly as physical particles. Quarks and antiquarks were constantly created from pure, raw energy. These newly formed particles would immediately destroy one another upon contact. This cycle of creation and annihilation continued in a chaotic dance. It was a literal battle for survival between matter and antimatter. They clashed repeatedly, each trying to dominate the early universe.
Guys?
Somehow, matter won the battle, leaving a tiny surplus that forms our world today. As the universe expanded further, the fundamental natural laws began to emerge.
The single superforce split into the distinct forces we observe today. These forces, like gravity and electromagnetism, would now rule the cosmos. The temperature dropped significantly, allowing more complex structures to form. We now enter the Hadron era, where quarks could finally bind together. Quarks combined in groups of 3 to form protons and neutrons. These new composite particles became the building blocks of all future matter. Next came nucleosynthesis, the creation of the very first atomic nuclei. Hydrogen, the simplest and most abundant element, was born. The universe was now a vast, hot soup of hydrogen and helium atoms. This atomic soup would eventually cool, setting the stage for the first stars.